ba naman? Online na nga, nalilate pa kayo. Kahit di na nga maligo. Ba't pa rin kayo nalilate? Mr. Aceret, Mr. Villanueva. Walang net kanina, sir. Anong magagawin mo? Siyempre. Ano bang connection mo at walang net kanina? Mayroon namang mobile data. Ginagawa mo pang rason ng internet. Sa ECE ka pa talaga magrarason. Marami namang means na para makakuha ka ng internet or mobile connection, data connection. PLDT. Nagloko ba talaga si PLDT? Even ato nung ko na, wala ito ng December. Medyo maintindihan sila dito sa amin. Kaya madami siguro affected din yan ni PLDT. Nag-roll out sila dito sa Dupax. Pero nauna na si Converge. Converge na yung connection ko. Ganon din nung mga first 2 weeks or 3 weeks ko with Converge. Medyo lagi silang may downtime. Pero ngayon naman wala na. Ikaw, Der, anong connection mo dyan? Sorry,
Sir, sa Cat B, hindi ko alam kung anong
Zen
nila.
Fiber. PLDT din ata sila. Zen Fiber. Nasa mo na nag-speed test dyan? Ano yung provider na pinipig niya?
Ay sir, di ko sure.
Hindi mo napapansin?
Hindi
So,
sir.
si Smart Telco ba or si PLDT minsan? Makita mo
Hindi,
nandun
sir.
ako kung alin talagang provider yung kung minsan. Zen Fiber, awan ko kung nakikikon din siya kay PLDT or not. O may sarili talaga siyang linya. Okay, angle modulation na yun tayo. So, angle modulation, class ng carrier modulation that is used in telco, telecommunications transmission system. So, pag angle modulation, it comprises yung frequency modulation and phase modulation, respectively based on altering yung frequency or the phase. And kaya isang pangalan, angle modulation. Altering that phase or the frequency to encode the message signal. So as a from an unmodulated carrier to a modulated carrier. Ito pag mataas yung frequency and then pag bumababa. Kung ito sana yung modulating signal, kapag at the peak, doon din tumataas yung sa frequency. At the lowest peak naman, hindi yung pinakamababa frequency doon sa result ng frequency modulation. Pag phase naman, every after 1 cycle. Tapos nagkaroon ng phase shift doon sa start of the signal. There. Every 1 cycle yung shifting. One important character of result of angle modulation is that the amplitude is kept constant. Same true din kanina dun sa amplitude modulation. Ano yung kept constant during or in an amplitude modulation? It is the frequency that is kept constant. Ito na sa angle modulation. The amplitude is kept constant. Okay, frequency modulation, a type of angle modulation wherein the frequency of the carrier is varied relative to the amplitude of the modulating frequency signal. General equation ng frequency modulation waves, ito naman, DC sine omega CT plus MF sine omega NT. So this time kapag modulation index naman ni frequency modulation, ano po yung ideal? Kapag frequency modulation naman, the ideal is that yung mataas naman si modulation index. Kasi nga, it corresponds to a more sidebands. And kapag more sidebands, yun yung mas nag-carry ng information. So, frequency domain standard ng FM. Ayan. So, ang dami niyang mga sidebands. Time domain standard. So, at the very peak, dun tumataas. So, dun naman peak at the negative part dun sa wave, dun pinakamababa yung sa frequency. Okay, in frequency modulation, one important parameter is your frequency deviation, yung amount of change in the carrier frequency. And pag titignan natin your produced by the modulating signal, it is your frequency deviation. Can be measured as the sum of your F max plus your FC, the carrier frequency, or pwedeng yung carrier frequency minus yung F minimum. The maximum frequency deviation occurs at the maximum amplitude of the modulating signal. At the maximum amplitude, your maximum frequency deviation occurs at that point. More onto that, the frequency deviation, the intelligence amplitude determines the amount of carrier frequency deviation. Yung intelligence frequency determines now yung rate ng carrier frequency deviation. So, the carrier deviation is proportional now to the amplitude of your modulating signal. But in order to take it as in equation, for the calculations of frequency modulation techniques. So we have now your proportionality constant, which is in hertz per volts. Directly proportional, you have to equate it to make it as an equation. So dapat yung frequency deviation mo is now with proportionality constant, which is in hertz per volts. Okay, example, find the carrier and modulating frequencies and modulation index ng and the maximum deviation ng FM wave represented by this voltage equation for FM. What power will this FM wave dissipate in a 10 ohm resistor? Carrier and modulating frequencies. O saan dyan yung omega C, saan dyan yung omega M? Dito yung sa may omega C, omega M dito. So, 6 times 10 raised to 8. So, 2 pi FC. So, it is 6 times 10 raised to 8 divided by 2 pi. Ito naman 1,250 divided by 2 pi. Yun na yung FM and FC. Next, yung modulation index. So, given na ba dito yung sa modulation index? Yes, ayun o, si 5. If naalala nyo yung sa equation. And then the maximum deviation of the FM wave represented. So, paano naman yung maximum deviation? How do we solve for the maximum deviation? Given din ba tayo nung sa mga peak voltages, ng modulating signal? So, modulating frequency is at 5. So, to calculate now your frequency deviation, it is your modulating frequency times your FM, modulating signal frequency, 198.94. So, your frequency deviation is calculated as 994.72. How about dun sa power, given na tayo ng voltage? So, we simply divide V squared over R. Pero ba yung voltage na given? At 12. Ito na yung equation. That is a peak voltage. Calculating with power. Ayan, V squared over R. So, converted to an RMS value. Since peak lang yung given as yung sa 12 volts. RMS dapat ginagamit in the calculation ng power. Even dun sa power electronics, it should be RMS. It's 7.2 kilowatts. Next, in a FM system, when the audio frequency is 1 kilohertz and the AF voltage is 2.5 volts, the deviation is 5 kilohertz. If the AF voltage now increased to 7.5, what is the new deviation? If the AF is raised to 10 volts while AF is dropped to 500 hertz, what is the deviation? Find the modulation in each case. Will you try this problem? Na-solve nyo na? Tapos na ako. Yung mga to, minsan, on the spot ko na lang din sinusolve para tignan kung nare-review ko din yung sarili ko. Tapos na?
Sir, 15 kilohertz sa isa. Sa umpisa. Ay, sa
Paano na?
unang tanong.
So, una, we need to compute for the when the audio frequency is 1
sensitivity.
kilohertz
Ay,
and the AF voltage is 2.5, the deviation is 5 kilohertz, sabi niya. So, deviation, tapos nagkaroon ng change, yung AF voltage now is naging 7.5. Tapos naging 10, pero yung nag-drop siya ng 500 hertz. What is the deviation and the modulation in each case?
sir, solving yung proportionality nila.
Yes, solve muna yung proportionality constant. So, paano? So, di ba yung deviation natin is your deviation over your VM. So, at first, deviation natin, diba given siya at 5 kilohertz, 5K over, una, it's at 2.5 volts. Ito yung K, diba? Ito yung hertz per volts, tama? So, we have 2 kilohertz per voltage. Tapos, pag nag-change yan yung VM daw is naging 7.5. Ano ulit yung calculation natin for the new deviation or deviation? So, deviation is K VM, tama? Diba nga, yung sa KEM kanina, tas proportional. So, kailangan natin ng K. Or meron tayong K, multiply lang natin. So, ito yung second deviation. Yung sa pag VM naman is at 10, ayun din. Times VM, K times VM lang. So, dito sa second, 2 times 7.5. So, meron tayong deviation of 15 kilohertz. Sa third, D3, kapag 10 volts na siya, so we have K times BM, so meron tayong 20. Tama? Kilohertz. So then we are asked to solve for the modulation in each case. Paano sa modulation in each case? Ano yung meron tayong formula kanina? Deviation can be calculated as your modulating index for frequency modulation times what? Times ano na? Your frequency of the modulating signal. Ano ba yung saan ba mga modulating signal is yung mga audio frequencies, audio voices, and BM/FM. So, dun sa first two, your modulating frequency is 1 kilohertz, tama? So, to calculate your MF, so D over FM lang. Your deviation over your FM. Dun sa first two, deviation is at 5 kilohertz over your 1 kilohertz. So that is 5. Tama? Dun sa una. And then, next, still, nung naging 7.5, AF still the same at audio frequency at 1 kilohertz. Deviation 5 over 1. Tama. Next, dun sa pangalawa, ganun pa din. MF2, the deviation is 15 kilohertz. Ayan, no? And then divided by your FM. Hindi man nabawasan, 1 kilohertz pa din. So we have 15. And yung sa last, 20 divided by the deviation is 20 over, this time it dropped to 500 hertz. So divided by 500. So this is, ilan naman to?
40, sir.
40. So nakuha po, everyone. Next. Balik na tayo. Ano na tayo sa kwan? Sa PowerPoint. Okay na?
Yes, sir.
Next. Carrier swing. So the total variation in the frequency of the carrier. Total variation. So the modulation index can also be calculated as deviation over FM. Ito another symbol for the deviation. Modulation index determines yung number ng significant sidebands. Kaya this time yung ideal naman na modulation index is for modulating FM frequency modulation is an infinite value, since it determines the significant number of sidebands in an FM signal. So yung modulation index for FM is directly proportional to the modulating voltage and at the same time inversely proportional to the modulating signal. MF, yung na-derive natin, wherein we have proportional to the voltage, modulating voltage, PM over your FM. Can be calculated as that. Proportional to your modulating voltage BM over now your FM inversely proportional sa frequency. For example, so modulation frequency range from 30 to 15 kilohertz permitted in a frequency modulation system together with a maximum deviation of 50 kilohertz. What will be the minimum and maximum possible values ng modulation index in the system? MF. So, given tayo ng frequency modulating frequency from 30 to 15. Tapos, meron na tayo ng deviation of 50 kilohertz. Para isolve yung modulation index, MF is equal now to Dmax over your FM. So, solving the minimum and maximum, paano? When solving the maximum, we divide it with the minimum. When solving with the minimum, we divide it with the maximum. Kuha. Deviation, pag kinukuha natin yung maximum modulating index, your deviation over now your minimum, which is 30. Pag minimum naman, divide it with the maximum. So, which is 3.3. Next, another parameter is the deviation ratio. The ratio of the maximum permissible frequency deviation to the maximum permissible modulating frequency. Yan, the max. Maximum permissible frequency deviation to the maximum permissible modulating frequency, or the deviation ratio. For an FM, yung maximum deviation for wideband, 75 kilohertz. Pag narrowband, it's 5 kilohertz. Mga maximum deviation for pag hindi given minsan sa problem. Take note on that. Tapos percentage modulation, so simple yung actual over the maximum para makuha din yung modulation index for frequency modulation. Ito, take note on this. This is the maximum deviation. This is standard for frequency modulation. Then, baka mamaya matanong what is the for FM frequency modulation. Ito kasi most of the time sa inyo, lumalabas lang sa mga objectives. Not more naman dun sa computation. Pero hindi natin alam, unti-unti may mga lumalabas din. Lalo sa inyo first batch, ito mga first batch ng K-12 kayo, tama? So, natin alam paano ngayon yung shifting sa board exam. So, kayo din yung first batch to take yung new table of specifications ng mga new board of examiners. Or kahit same board of examiners, siyempre, new basis of the table of specifications. Next, for an FM signal in the 88 to 108 broadcast bandwidth frequency deviation of 15 kilohertz, determine the percent modulation. So it's just simply, compute to, or ask for the percent modulation given now your FM and 88 to 108 broadcast band, tapos yung deviation maximum of 15 kilohertz. Okay, for the actual, it's 15 kilohertz, and then for the maximum, ito yung sa standard for FM broadcast, 75 kilohertz. So it is at 20%. Yung frequency spectrum naman ng frequency modulation wave, so ito siya, your J's, taken from your, anong table ulit yon? Yung makikita yung J, it represent now yung mga sidebands. Yung kay Bessel, diba? Bessel functions of your sidebands, wherein yung the number of your MF or the value of your MF determine now the number of the significant sidebands. Sidebands with frequencies yung JO. Ayon is yung JO carrier for the carrier. Sidebands naman yung mga J1 and so on and so forth. And may mga values ito. And if you will look into the image kung paano yung J1, J2, J3, J4 are the sidebands, your carrier is your JO. Ayan, I encourage you to memorize the first 5. The first 4 only, 0, 1, or yung 1, 2, 5. Most of the time, 1, 2, 5, 3, 4, and 5. Mga values na yan, very relevant minsan. Bessel coefficient, so yan, yung paano yung sa extended signal equation when we use the Bessel function. So yung mga J o J1, yun yung nakikita dito na values from the Bessel function. Okay, same with amplitude modulation ganun din sa FM. So we have power calculation. So the power in the carrier is given by VC squared over R. Or can be calculated given now yung sa mga from your Bessel functions. Mga amplitude levels kasi yon. J squared over 1 given that R at 1. In frequency modulation, the total transmitted power always remains constant. Take note on that. But with increased depth of modulation, the required bandwidth is increased. So the power in the side bands and J squared, the total power, so from your carrier and then the side bands. Etong mga J na yan is yung amplitudes or yung taken from the Bessel function. So that's why I encourage you to memorize yung first 5. Okay. Another problem, a frequency modulating signal has a definition of 3 kilohertz and a modulating frequency ng 1 kilohertz. Its total power is 5 watts developed across 50 resistive load. The carrier frequency is given at 160 hertz. Calculate the RMS signal voltage. We compute for the RMS signal voltage given the total power. Calculate the RMS voltage at the carrier frequency in each of the significant sets of sidebands. Calculate the frequency of each sideband for the first 3 sideband pairs. Calculate the power at the carrier frequency in each sideband for the first 3 pairs. Then determine what percentage of the total signal power is accounted for by the components described. Then sketch yung signal frequency domain. Kahit wala na, wag na sketch. Signal voltage. Okay, the signal power does not change with modulation. So does the voltage. Meron tayong given na resistance at 50. So for that voltage, ayun po siya. VT power is VT squared over RL. So yung RMS, so expected na yung calculated value ng V doon is also in RMS. The modulation index was be found in order to use yung Bessel functions. So pag 3, nakuha natin 3, we're in 3 kilohertz over 1 kilohertz. And yung sa Bessel function. So value ng 3, ito yung sa my carrier. So 2, 4, 6, we have 6 significant na values, significant sidebands.